Hello and welcome to Animated Education. Today we are going to talk about derivatives. So, before talking about derivatives, let's make clear what slope is, okay? So, let's say we have y-axis here and x-axis here. So, a slope of a line is a number that describes the direction and the steepness of a line. Okay, so let's say we have a line y is equal to x. To x. So, if we have 1, it would be 2 here, and our line goes like this. Something like that. So, in order to calculate a slope, we will take some delta x here, or maybe let's write it like that, x1 here and x2 here, and y1 here and y2 here. So, and we would calculate our slope. So, to calculate slope, it's usually written as k or m, okay, and it's calculated, y2 minus y1 divided by x2 minus x1. It can also be written simply as delta y divided by delta x. So, if we have an equation like this, a function like this, so our slope would be 2, because if we divide both sides by x, we get that our m is equal to y divided by x, and it is equal to, okay, and to any given point in that line, our slope will be 2. Well, that's because it's a line, okay? However, if we have a different function, for example, a function that looks like this, that this is a function of a square root of x, well, at least something similar to that. So, the slope isn't equal to all the areas here, because if we take some, that's x-axis and that's y-axis, if we take some delta y here, okay, and we take delta x here, okay, so it's delta y here and delta x here, delta x1 and delta y1. It's not the same as here, okay, so it's different. Delta x2 here and delta x1, delta y1 here. So this delta y1 divided by delta x1 is not equal to delta y2 divided by delta x2, I'm sorry. And mathematicians thought about it. So how could we determine a slope at any given point in this graph, okay? So a slope here or here, how we could do that? So they came up to a conclusion that if we draw a tangent line to some point, for example here, okay, tangent line, okay, so tangent line is a line that intersects with only one point of our graph. We could calculate a slope of that line, of this green line, of this tangent line, and we would get a slope for this point. Let's call it point A, okay? So how could we do that? Well, let's see. For this graph, we could take this delta x and this delta y. We could do it in a smaller scale like this, and we could come closer and closer to 0. So we say that our x approaches 0, and when our x approaches 0, our delta x approaches 0, we get a slope of a tangent line. Okay, I hope that's clear. So now let's move on to the definition of a derivative. A derivative is a slope of that given point. So they say that a derivative of a function f of x, okay, this is a sign that it's a derivative. You could also write it like that, df of x divided by dx. Okay, that's a sign that it's a derivative. So they say that let's take a limit, then x approaches 0. Don't worry if you don't know what a limit is. It's basically a mathematical saying that something approaches some number, okay? In our case, delta x approaches 0, and delta y divided by delta x. So look at our graph here. We are simply saying that our x is so small that it is basically 0, but it's still not 0, but it's like 0.000000 and so many zeros and 1. Okay, it's very, very small. It's a differential. We can continue this equation, and we get that limit, then delta x approaches 0 of delta f of x divided by delta x. From this equation you can see that we are saying that delta y is equal to delta f of x, and that is essentially true, because a function f of x, we give some value of x, and in return from this function we get a value of y. So we actually don't change anything here. We simply write it instead of delta y. We write delta f of x. Now we can write what delta f of x is. Okay, so delta f of x is f of x plus delta x minus f of x, okay, divided by delta x. So here's what we say. We say that, let's say we have a function f of x, or f of 1, okay, f of 1, and it's equal to 2. It's any function, I don't know. So, and we say that f of 1 plus delta x, and our delta x is, for example, this 0.001, and we say that it's 2.1. okay, so our delta f of x will be 0.1. So, but our delta x here is actually very close to 0. It's not 0.001, it's much smaller. But here's what we essentially did. Now, this is basically the definition of a derivative. I forgot to put a limit here, so let me rewrite it. So, limit, then delta x approaches 0 of f of x plus delta x minus f of x divided by delta x. This is a definition of our derivative. This is equal to a derivative of a function. Okay? So now why I am telling you this and why it is useful? Well, I want to show you how all the formulas that I'll give you very soon is actually get. I mean, how. Let's say we want to calculate a derivative of a function, and our function is f of x is equal to 8x minus 1. 8x minus 1. We want to know what a derivative of this function is. So, if you already are familiar with derivatives, you could easily say that this is equal to 8, okay? But I want to show you how these formulas are get, okay? So, here's what we essentially are doing. We are saying that, that f of x, the derivative of f of x is equal to limit, then delta x approaches 0, 8. Now we are putting this, okay? So what I need to write this here, okay? So how to do that? Instead of x, I'm putting x plus delta x, and I'm putting it here. So okay, let me write it, maybe it will be clearer. So f of x plus delta x is equal to, of this function, it is equal to 8x plus delta x minus 1, because instead of x I need to put x plus delta x in this function. What I get, x plus delta x minus 1 minus f of x. F of x is this, so I need to rewrite it. So minus 8x minus 1, and it is divided by delta x. Let's continue this. So we need to open these brackets and also here. So here's what we'll get. 8x plus 8 delta x minus 1 minus 8x plus 1 divided by delta x. Now this and this will cancel out, also these two, and we are left with 8 delta x divided by delta x. So it is equal to 8. From this we can say that the derivative from a variable in the first power is equal to 1, okay? Because if this would, you see, a derivative of a constant is 0, as we can tell, and a derivative of 8x is equal to 8. So that means that the derivative of x is equal to 1. Here's what we actually got from here. Now here's another example. Let's say we have a function f of x is equal to f squared. So now we need to do the very same thing. So we are taking a limit, then delta x approaches 0 of this function. So we are using this formula, nothing new. So this will give us that x plus delta x square minus x square divided by delta x. It is equal, we need to use a formula here to open these brackets. We get that it's x square minus 2 times x times delta x plus, excuse me, this is plus here, plus delta x square minus x square divided by delta x. Now these two will cancel out, and here's what we're left with. We are left with 2 times x times delta x plus delta x square divided by delta x. Now it's not so obvious as in our previous example, so we need to take our delta x before brackets, so and we get 2x plus delta x divided by delta x, and this is equal to 2x plus delta x. Now, those who already knew something about derivatives, you knew that we should have gotten just 2x, okay? This should have been our answer. So what to do with this? Now, you see, delta x approaches to 0, and we can't divide by 0, so that's why we can't have it in our denominator. But once it's left alone, we can simply say that this is equal to 0, and our answer is 2x. So, I talked for very long now, and I hope you understood how these formulas that I'm showing you right now is actually got. So, other examples requires a bit more advanced algebra, but basically you could get all these formulas just by doing what I've shown you just now. So I don't recommend doing it because it consumes time. I suggest you just learn these formulas. I don't think that these formulas are very necessary, like these, because I haven't needed them actually for myself in high school, but other ones is really useful and you should remember them. So now let's calculate some derivatives. Actually, before calculating derivatives, I need to tell you about sum rule. Okay? It's very easy. It basically says that if we have two functions, f of x and plus g of x, and we are taking a derivative of both of them, we can take a derivative of f of x and a derivative of g of x. So that plus doesn't change much, okay? Now the other rule is called a difference rule. And it's basically the same thing. So if we have f of x minus g of x and we want to take a derivative of both of them, we can simply take a derivative of f of x minus a derivative of g of x. Now let's move to our examples. Let's say we have f of x is equal to 3 and we want to calculate a derivative. So 3 is a constant, it's not a variable, okay? So our derivative will simply be 0. Let's say we have f of x is equal to 7x plus 2. Now we need to calculate a derivative, so I'll write everything consistently, okay, and we are taking a derivative of this. So we are basically taking a derivative of 7x and 2. So you already know that a derivative of 2 will be 0, so this will be 0, and a derivative of 7x, 7 is a constant, and when a constant is multiplied to a variable, we can take out that constant. But when a constant is alone, like our 2, we need to take a derivative of it. So it is 7 times, and x will give us a derivative of x will give us 1. So our answer is 7. Let's say we have f of x is equal to 4x cubed. Now our derivative will be 4 because 4 is a constant and it's multiplied to the variable, times x cube derivative. So it is equal to 4. We are using a formula that I showed you earlier, that table. Okay, so in that table we saw a formula that it is 3 times x, 3 minus 1. And that gives us 12x squared. Let's see, we have f of x of a square root. So now you could remember, and I suggest that you remember, that a derivative of a square root is simply 1 over 2 square roots of x. However, it's not necessary to remember. Okay, so we can say that a square root of x is the same thing as x to the power of 1/2. Okay, so now we are using power rule, and this will give us 1 over 2 times x 1 over 2 minus 1. So it is 1 over 2 times x in the power of minus 1/2, and that gives us that it's 1 over 2 times x to the power of 1/2, and it is basically the same thing as 2 square roots of x. Let's say we have f of x equals to 6 to the power of x plus x. Now the derivative will be, to calculate the derivative of 6 to the power of x, we need to look at our table, and we will see that the derivative of that is 6 to the power of x, so it's the same thing times a natural logarithm of 6. Now, in order to calculate a derivative of x, well, it's 1. Okay, I even proved you that. So this is 1. Also, an interesting thing. So if we have a function f of x e to the power of x, where e is 2.6 and so on, then a derivative of this function will be e to the power of x. Now, why is that? This is because if we are using the same formula as we did for this, we would get that we're multiplying a natural logarithm of e, and a natural logarithm of e is equal to 1, because a natural logarithm of some number is the same thing as logarithm with the base e of that number. Now, what if we have f of x equals to logarithm with the base 3 of x to the power of 5? Now, we could use chain rule, but I haven't talked about it yet, and I'll do it in our next video. So for now, and it's not a very good idea, okay, because it's more complicated to do that. We can simply use properties of logarithms and move this 5 here. So here's what we will get. We get that our function is 5 times a logarithm with the base 3 of x. Now, for this logarithm, we have a formula from that white table. So f of x will be 5 times 1 over x times a natural logarithm of 3. As you probably already noticed, calculus really likes natural logs, so it actually helps to remember how calculating derivatives. let's say we have f of x equals to natural log of x plus 4x minus 3. So here's what we need to do in order to calculate a derivative. So firstly, let's find out what the derivative of natural log of x is. So from that table we can see that it's 1 over x. Now a derivative of 4x is equal to 4, and a derivative of a constant is equal to 0. So this will be equal to 0. Okay, so that's our answer. Let's say f of x is equal to sine of x plus 3 cosine of x. Now the derivative of this will be a derivative of sinus x will be cosine x. A derivative of 3 cosine x will be minus 3. A derivative of cosine is negative sine x, okay? So this will give us 3 times sine x. So yeah, that's about it for this video. In the next tutorial, I'll show you how you can calculate more complex derivatives using chain rule, product rule, and quotient rules. I hope you understood everything, and see you next time.